A cannonball is fired from ground level with a velocity of 25 meters per second at an angle of 53 degrees with the horizontal. So I'm going to mark up this picture that they gave me with the details. And I want to point out that over on the right-hand side, it says make a chart. What they're saying is, what do I know in the X direction? And what do I know in the Y direction? Let's fill in all of our information. So they help us in part A with filling out part of that by making us find the value of the velocity in the X direction and the velocity original in the Y direction. So let's start there. To find this, we're going to use basic right angle trig. In the X direction, we're going to use cosine 53 equals Vx over 25. So the velocity in the X is equal to 25 times cosine of 53, which is 15.05 meters per second. In the Y direction, I'm going to use sine 53 equals velocity original in the Y over 25. And so then the velocity original in the Y, when you plug it into a calculator, is equal to 19.97 meters per second. I can start filling some of these things into this chart. In the X direction, the velocity is always 15.05 meters per second. In the Y direction, I know that the original velocity is about, I'm going to just round it off to 20 meters per second here, but I will use the 19.97 as we go. I don't know how far it goes horizontally. I don't know how long it's in the air. What I do know in the Y direction are a couple of hidden things. One of those is that if I pick this original vertical velocity to be a positive 20 meters per second, the gravity would then have to be a negative 9.8 meters per second squared. I can fill out this chart with some more things. If I look at the entire problem, one thing that's hidden is that the vertical displacement is 0. If I only go to the highest point, I know that the final velocity at that point is equal to 0. I'll say that again. I'm going to draw a picture of what I just said. Here's the motion. At this highest point, the velocity in the Y direction is equal to 0. And if I cut this problem in half and only look at the first half, that's actually going to be the final velocity in the Y direction. The original velocity in the Y direction is equal to 19.97. This first question, letter B, how many seconds after the ball is fired does it reach its maximum height? For that problem, I'm actually looking for time. So just like we did previously with our acceleration equations, I find the right equation. It's something like final velocity is equal to original velocity plus acceleration times time. Again, if I'm only looking at the first half of the problem, the final velocity is 0. The original velocity is 19.97 meters per second. Acceleration is negative 9.8. And time is what I'm looking for. When you do the algebra and plug it into a calculator, you find that that's equal to 2.04 seconds. Letter C, what is the maximum height? So essentially, I'm working off of this table up here again, and this time I'm looking for the distance. I can use the time that I just found because I am only going to the highest point, or I can go back and use just VO, VF, and A. And so pick your favorite equation. So here you could use like a D equals VOT plus 1/2 AT squared. That would work perfectly fine. I am actually going to use VF squared equals VO squared plus 2AD. The final velocity at the highest point is 0. The original was 19.97. Don't forget the squared. Plus 2 times negative 9.8 times the distance, which is what I'm looking for. So again, I'm not going to show the algebra, but when you type it into a calculator, you end up with a distance of 20.3 meters. Letter D, what is the total time that the ball is in the air? Well, I know that it took 2.04 seconds for it to rise to the highest point. And because there's no air resistance, there's no external forces, there's nothing else going on here, it's going to take 2.04 seconds for it to fall from its highest point. So that means that the total time in the air is equal to the half time times 2, which is 4.08 seconds. And then how far from the cannon does the ball land? I'm going to go back up to this chart that I made and recognize that in the x direction, the only equation I ever use is distance equals velocity times time. And the only thing that can travel between these two columns is time. Then the question becomes, which time do I want to use? So I'm going to write down the equation, d equals vt. I know that the velocity in the x direction is 15 meters per second. So 15 times. Now, because I'm looking for how far from the cannon does it land, I need the entire time, which is 4.08 seconds. 15 times 4.08 is 61.3 meters. And that's a cannon problem.